Hello friends, this is Kaushik. Today I'm going to cover a really important topic on unsupervised machine learning technique, which is hierarchical clustering. So today we're going to do customer segmentation on RFM analysis. And what is RFM analysis? Imagine you work in a e-commerce company, let's say Daraz, Ivali or Sheba XYZ maybe. So now you are given a task to segregate customers on three attributes or three behaviors. Their recency of visiting your website, how frequently they visit your website, and the total revenue contribution to your company, right? So here it is: R for recency, F for frequency, and M for monetary. I mean the revenue, which is the revenue contributed to the company. And how do we segregate customers based on these three different behaviors or attributes? So the code behind it, we're gonna see it today. So let's begin. So first we start with importing the relevant libraries, and we import warnings, NumPy for mathematical manipulation, pandas for data frame manipulation, matplotlib and seaborn for plotting graphs, datetime for working with the dates, and sklearn to pre-process, scale, analyze the data. And from SciPy, we work with a hierarchy. Since we're going to do hierarchical clustering, so we're going to need these libraries. So moving ahead, we what I did is I loaded the data. So online retail.csv. So the columns we have is invoice number, stock code, the description of the products, quantity, invoice date, unit price, customer ID, and the country the customers are living in. So after loading the data set, the next thing we do is cleaning the data. So, so what I find is we have null values in two columns, description and customer ID. So in this particular analysis, we have to understand that we're gonna be identifying those customers, right, which we are going to segregate on their different attributes, the different behaviors, as I have mentioned before, the recency, frequency, and the revenue contribution, which is the monetary. So which means any row which does not have customer ID is not, we won't be needing that row, right? Because customer ID is a very crucial column in this analysis. So after dropping all the null values, so now we have a clean data set here. The code for it is here. Now let's prepare the data for modeling. And first we find the revenue column. And how do we do so? We compute it by multiplying the quantity with the unit price. So, and we have the revenue column. And now we have to subset this data set in three different subsets, which is, first we start with the revenue contributed, and we find it how? So we group by customer IDs and aggregate all the purchases, which is the revenue we have received. So the aggregate, the total sum of revenue contributed by each customer, and after grouping by customer with the customer ID, and we find this subset. And here we have each unique customer ID and the total number of revenue they have contributed, right? So the what is the next subset? We have to find frequency. And how do we do so? We find it same in the same manner. We are grouping by customer ID to in order to find attributes of each unique customers. And the transaction, which is the invoice number, we are finding the count of total transaction, right? So each unique customer ID and the total transactions they have made, the total count of it. So here we have it. And the next one, which is quite important, a little bit difficult, it might be difficult for you to understand, but I will try my best to explain. All right. So this is to find out the recency, how recent the customers were in visiting your website, right? So first what we did is formatted the invoice date column. We had the pd.toDateTime function. We use that basically. And after that, the data we make another column, duration. There what I did is uh, first found out the maximum date and subtracted the previous transaction dates. So basically, for example, a particular customer who has made a purchase on 10th January, 5th January, 6th January, 7th January. So 10th January, the maximum is the last date, which is this portion. And and we're subtracting all the previous dates, right? So for example, if a customer has done two transactions on 9th and 10th, so 10th minus 9th, so the recency is 1, right? So 1 day. I hope I could understand. I could explain it. So let me show you further. So after subtracting the previous dates with the last date, we get this values, and then same procedure. We group by customer ID to find out the information of each unique customer, and we take the minimum of each duration, right? So why do we find the minimum? To In order to find the recency, right? After finding the differences between the last purchase and the previous purchase, and from that column we take the from the duration column we take the minimum in order to find the recency. Guys, I will be expecting those the viewers to go through the code personally, because I will be uploading the Jupyter Notebook. The link will be attached right below the video, so please go through it for your better understanding. All right. So here, see, we have 325 days, 1 day, 74 days. This is the recency. And we also have time mentioned here. So we won't be needing that, right? So in order to get rid of it, what we did is, this is the dt.days, this function. We are only left with the day values. All right. And obviously this three subset, recency, frequency, and revenue contribution, we are merging all these three subsets to form another data frame, a different data frame that is which is only focused on these three attributes. So after merging, this is the code, and here the data frame it is. Okay, so the next step is outlier treatment. So guys, we have to understand that in cluster analysis, outliers can severely hinder the analysis. So we have to get rid of outlier. And how does it hinder? It's a very conceptual explanation. We won't be covering that. So in order to get rid of outliers, what the very basic rule, the golden rule we can implement, that is taking data up to the interquartile range, right? So this is the code for it. So usually in interquartile range, in interquartile range, we take 75th percentile, but here I have kept 95th percentile in order to keep the maximum data available, right? After getting rid of the outliers. So after the next thing we do is scaling the data. So what is scaling? Basically, so scaling is we have different columns with different scales of values, right? So here there's a different scale of values and hundreds, and there's a different scale of values, and here the values goes to thousands. So obviously, when we're going to do cluster analysis, we have to scale all of them on a standard scale, like if in order to make a better analysis. So in a standard scaling, the maximum value is 1, the minimum value is -1, and this does not hamper any information. This is one of the crucial thing to do, scaling. So after scaling, now here is the scale data. The next step, it is Hopkins Statistics. So when we are going to do hierarchical clustering, it is not important to, it's not mandatory to finish the, it's not mandatory to the Hopkins test, because it is important in k-means clustering, because when we have when we group by different data points, I mean here the customers, we have to basically understand whether the groups of different groups are equal, are proportionately, I mean whether they're distanced well enough. In a in the best explanation, I can tell whether the data is eligible enough for in order to go for clustering. So for those who does not have who does not know, who does not have a conceptual idea about what clustering is, the best explanation, this is what I can give, whether the data set is good for clustering. So we have 0.95%, so which means it's quite a good data set, well pre-processed, right? So the next thing is, what we do is find the dendogram. So this is the code for it, and it's very simple. We just the hard coding is done in the library. We just import it and just instantiate. We mentioned the method, it's complete method and Euclidean metric. So this is the dendogram, and this here is, we have to make a very important decision. We have to decide a cutting edge, because the data points have hierarchically risen up, and here we have to make a decision how many clusters we want to make. So we have previously decided we're going to make 3 clusters in order to find our RFM, in order to find customer segmentation, the RFM analysis, and we have also already decided the clusters, the recency, frequency, and monetary, the revenue contribution. So that's why we took n clusters equals to 3. This is the code for cut tree edging, deciding the clusters. So now reshaped it in order to incorporate it in another column, edit column. So here it is. So see, this is the information of all the customers based on different attributes. So attribute 0, cluster 0, this is cluster 1, cluster 2. So depending on different, these are customer segmentation, depending on different behaviors, you can understand that which customer belongs to which group, right? Which behavior, which particular behavior, right? So for a better understanding, let's go through graphs and different box plots. So here, this is the recency part. So we understand that this group of customers are basically more recent, who they are basically those customers, not more recent, as in like the customers for very long time has not attended or have visited your website. For example, this is a 150 days, like more than 150 days. That means a particular customers, there are customers who has not visited your website for more than 150 days. So median value is more than 50 days. So basically it's less recent, less recent. So these two are the customers who are very recent in your uh, website, who often visits your website. So this is the frequency part. So obviously they are less frequent, very understandable, and these two are very frequent. So whatever the marketing strategies, after you give this analysis to to the marketing department, so they are going to devise different marketing strategies depending on different groups of customers, right? So these two are the customers they might be putting their more focus on, or maybe these are the customers they might want to put more focus on in order to make them visit visit the website even more. So it's totally their decision. So next is revenue part. So again, cluster 2 is very important. It means these are the customers in this group are basically are contributing highest to your revenue. Then comes this one, the second, cluster number 1. So basically what marketing strategies are going to be taken are definitely going to be decided by the marketing officials, professionals, but being an analytics professional, your job is to identify the analytical parts and identify those customers and give this crucial information to the marketing department or other authority in order to make the right decision for the company in order to improve sales or revenue or whatever the objective is. So that is all, friends. Thank you so much. I hope you like this video, and if you do, please hit that like button and also do subscribe to my channel. Thank you.